questions. In the next questions, they say a shoe factory used 3 machines for printing logo operations. 25% of the shoe logos are printed using machine X. 35% of the shoe logos are printed using machine Y, and the rest are print using machine Z. The probabilities that the selected shoes logos printed were defective are 1%, 2%, and 5% come from machine X, Y, and Z respectively. So, in these questions, first we need to identify the keyword in the questions. So, in the questions, there are 3 machines, and it says that each machine will has a different probability of producing defective logo, with machine X having a 1% chances, machine Y a 2% chances, and machine Z a 5% chances. To visually represent this information, they ask us to use a tree diagram which shows the paths and probabilities for a selecting machine. So here is the answer for the tree diagram. As you can see, every branches has the defective and non-defective branches. Okay, so for the next questions, they ask us to find the probability that a randomly selected shoe has defective logo. So, to find the probability that a randomly selected shoe has a defective logo, we need to calculate PD by adding the probabilities of selecting each machine. As you can see, I already highlight the formula. So, we need to adding the probabilities of selecting each machine X, Y, and Z and having a defective logo. So using the given information, we found that PD is equal to 0.0295. And to determine the probability of shoe having a non-defective logo, we need to subtract PD from 1, and the result will be 0.9705. And that's all. So we move to the next questions. So for the last questions, we need to calculate the probability that the shoe logo printed using machine Y, given that it is not defective. So to calculate the probability that a shoe logo was printed using machine Y, given that it is not defective, we use the formula that I have stated. So by substitute the given probabilities, we found that the formula will equal to 0.35 multiplied by 0.98 divided by the complement of the probability of a defective logo, which simplifies to 0.3534. And that's all for my individual video assignment, and thank you.